And good morning, Math Masters of Room 502. Welcome to yet another edition of Mr. Leggett's Eureka Math in the Morning. Let's get right on it. We're going to go to page 139. And today's date is 03/11/2020. Actually, I'm doing this yesterday, so it's 3/10. Let's find out what's going on here. Find out what we know. Each rectangle represents 1, okay? Represents the number 1. What we're going to do is we're going to compose the shaded fractions into larger fractional units. What does that mean? We'll find out. Also, express the equivalent fractions in a number sentence using, circle that word, division. We're not using multiplication, we're going into division. The first one has been done for you. So notice what we did here. We had 2 out of 4. So we took 2/4 and we're making larger fractional units, right? So we did 2 divided by 2 is 1. And 4 divided by 2 is 2. So it was like if we join them back together to show that it's 1/2. And this is going to make sense, I hope, if we continue on. Let's look at our first fraction over here. We all know what this is. 1, 2, 3, 4, 5, 6. 3 6, right? Our 1/2. But what would we do to get the 3 6 to equal 1/2? Do we see the 1/2 there? See? There we go. So 3 6, we got to get it to equal 1/2. So we're going to get larger fractional units. We're not going to multiply. We're going to do the opposite because instead of getting smaller fractional units that are equivalent, we're getting larger units. So let's put the opposite of multiplication, division, right here. 3 6. Now, what I can do is just divide, in this case, the numerator by itself. 3 divided by 3 is 1, and 6 divided by 3 is 2. Making sense? I hope so. Let's continue on to C, and let's see what this is all about. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I know my denominator is going to be 10. What is my numerator? 1, 2, 3, 4, 5. 5. So we're trying to get it back to 1/2, right? As we can see, we can plainly see that's 1/2. How do we do this? We divide. Let's get to it. 5/10 equals, we'll set up our problem like this. And it's definitely going to equal 1/2, right? Because there it is, plain and simple. We get rid of those lines, we see 1/2. So let's see how we do this. Let's put our division symbols right here. So that's how this is setting up to look. And then we go 5 divided by 5 equals 1, right? And 10 divided by 5. Note, just like we were doing before, same number, 5/5 right there. 10 divided by 5 is 2. So we get back to 1/2. We've got another 1/2 right here. I'm going to go ahead and circle that 1/2 and circle this 1/2. What was this originally? We have 1, 2, 3, 4, 5, 6, 7, 8. That's going to be our denominator. What's our numerator? 1, 2, 3, 4, the shaded areas. So it's 4/8. But we're trying to get it back to 1/2. Erase all those lines right there. So we'll put our division signs right here, and we set up our problem just like we were doing before when we were making smaller units, but this time we're making larger units, so we're going to divide. So let's do 4/8 divided by, well, I know both of these are divisible by 4, so let's go ahead and put 4 right there, because we want to get to 1/2. And what's 4 divided by 4? Well, 4 times 1 is 4, so there we have that. 8 divided by 4, I know 4 times 2 is 8, so we have it right there, 1/2. Got it? I hope so. Let's turn it over. All right, let's see. These are starting to look a little more difficult, but that's okay. We're all very smart in this classroom. It says compose the shaded fraction into larger fractional units. Same thing we're doing on the other side. Express the equivalent fractions in a number sentence using, there's that word again, division. All right, so we start off with, picture if you will, no line right here, just deek deek. We start off with what? We would start off with 1/3, right? So, but in this case, we have 1, 2, 3, 4, 5, 6. It's 2 6, and we're trying to get to 1/3. So we have 2 6, we're going to divide. Going to put my division symbols right here where we used to put our multiplication symbols. So it's just like yesterday and the day before, except we're using division, right? 2 6. 2 divided by 2, and 6 divided by 2. Remember, these got to be the same. So what's 2 divided by 2? That's 1. And what's 6 divided by 2? 2, 4, 6. That's 3. And we get back to our original 1/3. Let's go over here. Start off with 1, 2 is our numerator. And 1, 2, 3, 4, 5, 6, 7, 8 is the denominator. So we'll set up our problem just like we've been doing, right? Division instead of multiplication. Put our 2 8s right there. So that's how our problem is set up to look like. What if we just divide that 2 by 2? Because as we're trying to get to, we plainly see this is 1/4, right? If we erase this line right here, it'd be 1/4. So let's divide each by 2. They're both divisible by 2, right? 2 divided by 2 is 1, and 8 divided by 2 is 2, 4, 6, 8 is 4. And we can see that that 1/4 definitely is that 1/4 right there. If we just got rid of that, it would be a clear case of 1/4. Let's try something a little different now. We're going to write what we see here. So you have 1, 2 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So set up your 2/10 equals, and let's go ahead and determine what this is going to equal, okay? Erase that line and we have 1, 2, 3, 4, 5, 1/5. So we're going to break it down, or up actually, larger units, into 1/5. So let's start with our 2/5 here. And once again, we can divide by what? Well, we can divide by 2, right? They're both divisible by 2. 2 divided by 2 is 1, and 10 divided by 2 is 5. 2, 4, 6, 8, 10. All right, let's try it the same way on this one, on D. So we have a total of 2, 4, 6, 8, 10, 12. That's our denominator. And let's go to our numerator. It's going to be 1, 2. Set up our problem. And we could see that this was originally, let's pretend that wasn't there before we drew that line, we'd have 1 out of 1, 2, 3, 4, 5, 6. It was originally 1/6. So we can do 2/12. What are we going to divide it by? Divide it by 2. They're both divisible by 2. 2 divided by 2 is 1, and 12 divided by 2, 2, 4, 6, 8, 10, 12 is 6, and we get 1/6, okay? Let's go to E. What happened to the size of the fractional units when you compose the fraction? Instead of decomposing it, we're composing it. Well, they got larger, right? Because we took out that, so then we have a larger unit. Picture, if you will, the brownie pan. Those are 2 little pieces, but if we never cut them or we put them back together somehow, we'd have 1 bigger piece there. So, the fractional units increased in size. Okay, so the fractional units increased in size. They got bigger. They became larger units. Okay, you see how that works? Before, it was 2/10, and then we made it 1/5. So it was a much bigger unit, right? Still equivalent though, just fewer pieces. Like last time it was equivalent but more pieces. This time it's equivalent but fewer pieces. We're doing it in reverse. Okay, what happened to the total number of units in the whole when you compose the fraction? The total number of units, what did they do? Let's go take a look. They started out with 2 out of 12 and then became 1 out of 6. So the total number of units decreased. The total number of units decreased in size, period. So that's how we do it. And oh my goodness, here comes Princess Yvonne. Oh, we're talking about division. Yes, we're talking about dividing, using division to compose fractions. Oh, so just the opposite of what we do past 2 days. Yeah, it's just the opposite. Take a look. I'm looking. We can see that instead of what we were doing before, we went from 1/6 to 2/12. This time, you go from 2/12 to 1/6. I see it's complete opposite. Yes, it is the complete opposite. I'm so glad that you learned that, Princess Yvonne. Oh, I try my best to learn. Well, you do a remarkable job. So we could say here, let's just kind of do another review of, let's do 2/10. Okay, let's do 2/10. Here's the 2/10. Yes, I see. There are 10 units and 2 are shaded. Yes, exactly. So we divided them by 2. Yes. And so if you could picture just getting rid of that line, what would you have? Well, you'd have 1/5. 1 out of 1, 2, 3, 4, 5. It makes perfect sense to me. Yes, it does. Thank you, Princess Yvonne, for dropping by and helping us out as you always do. Let's go to number 3A. We're going to go to page 341. I should have told you to pick that one out when you were getting the other paper out. 140. 341. Boy, I am tired. It's page 141. Excuse me. You guys are thinking 341. What's he talking about? So, in the first area model, show 2/6. Okay, we can do that. Let's do 2/6. We'll go 1, 2, 3, 4, 5, and 6. And I'll shade in 2. I don't have my trusty yellow pencil, but I'll shade in 2. So we created our 2/6, okay, in the first area model. In the second area model, show 3/9. Aye, so we're going to be kind of small here. 1, 2, 3, 4, 5, 6, 7, 8, and 9. And we're showing 3 of those, okay? 1, 2, and 3. Okay, 3/9. Okay. Show how both fractions can be renamed as the same unit fraction. Wow, what can they both be renamed as the same unit fraction? Well, let's find out using, ding, 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 division. So we're starting out with 2/6 equals, put our division signs here. So 2/6. What can we divide by? How about we divide by 2? I like that idea. So 2 divided by 2, 1. 6 divided by 2, 3. Look at that, it's 1/3. It is. Let's try this one. We start out with 3/9. We're going to use division again. So 3/9. Let's divide it by 3 because I know 9 is divisible by 3 too. 3 divided by 3, 1, and 9 divided by 3, 3, 6, 9 is 9. We did it. Okay, then it says express the equivalent fractions in a number sentence using division. Well, lo and behold, we already did that. We already did it. Okay, let's go on down to our next set here. It says, in the first area model, show 2/8. Boy, they don't give us much room. 1, 2, 3, 4, 5, 6, 7, 8. In the second area model, show 3/12. Well, that's even less. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wow. So we have 1, 2, 3, 4, 5, 6, 7, 8, and we're showing 2/8. There's 1 and there's 2. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and we're showing 3/12. It says, show how both fractions can be composed or renamed as the same unit fraction. Well, that's what we're going to do. We're going to do it right down here. Let's go for it. Let's just go right into 2/8 equals, let's put 2/8 here, a division symbol here, and 2 divided by 2, and 8 divided by 2. Remember, these always got to be the same. It can't be different. Sometimes on your exit tickets I see them different. Got to be the same. 2 divided by 2 is 1, and 8 divided by 2 is 4. Huh, you're telling me that's 1/4? Maybe. Let's see what 3/12 equals. Well, 3/12 equals, so we have 3/12 divided by, and let's see what we're going to get. We're trying to get to 1/4. Do you think we could do it to show that they're equivalent? Because they are. Well, 3 divided by 3 is 1, and what's 12 divided by 3? 3, 6, 9, 12. It is 4. So it is 2 1/4, and they are absolutely, positively, definitely equivalent. I hope you enjoyed that. Remember, if you want to do the homework over the weekend, you'll be eligible for fantastic prizes. Hope you enjoyed this edition of Mr. Liggett's Eureka Math in the Morning.